Well, we're used to thinking of space as being big. We have all these wonderful pictures of the Hubble telescope and showing billions of galaxies miles and miles away. But in fact, we don't have to go very far from Earth to illustrate quite how much space there really is in space. These classic images of the solar system, they all make it look very cozy, but of course the solar system is really nothing like that. And there is an enormous amount of space for these tiny planets to circulate in. There's as much space between the Sun and Jupiter as there is between Jupiter and the next planet out, Saturn. So I want to try and create some kind of model universe, give us an idea of the true distances that we're talking about here.
There are a lot of illustrations about the size of the solar system. There are many kind of films and animations, but almost all of them seem to miss the most significant scale of them all, the one that really gives us a true idea of the distances involved between the solar system and the next stars. So what I'm going to do is I'm going to choose the scale of 1 meter to 20 million kilometers. And that gives us a sun of about 7 centimeters. This is a tennis ball. It's a fraction smaller than 7 centimeters, but it will do. In my book, I use the illustration of a par 4 golfing hole of about
375
meters long to give you, which is about the dimensions of the solar system, say from the Sun to the average orbit of Pluto.
375
meters. But I've no time at the moment to go down to a golf course, so I'm doing this illustration here. My village is a little local fronton.
Here's on the same scale. Here we have the Earth right next to the Sun, so you can see the Earth. The camera can hardly focus on that ball bearing, 0.5 millimeter in diameter. I'll also show you on the same scale. Here are the gas giants: Jupiter, Saturn, Uranus, Neptune, next to the Earth. They all fit between the Earth and the Moon. I'm going to put this ball down on the black tarmac as some kind of analogy for the bright yellow sun and the blackness of space. Okay, we're going to focus on the sun, and we're going to pull the camera back to the point of view where it would be from the Earth's orbit. And as you can see, it's pretty much what we do see in the sky. Heading to my house along the road behind the fronton here, 375 meters along, we would find Pluto. The reason I've chosen this particular scale out of all the illustrations and scale models that you can find is that I think this gives you the most immediate, graspable nature of the difference between the extent of our solar system, big enough space there it is for the planets to move around in, and the distance to our nearest star. Okay, well, so here we are in the fronton, and we're going to drive now. This is our solar system, this is our sun, and now we're going to drive from here to Pluto. Well, here we are at Pluto. The edge of the solar system is just up there, and Voyager is a little bit beyond. And Pioneer 10, left at a very different angle, is probably up in that direction at a similar distance. So you can see the whole of our model solar system is about 400 meters in length from the Sun down at the fronton to the edge of the solar system. Now, let's see where the nearest star is. Now, in our model universe, let's fly from here to the nearest star. Berlin Airport. Imagine what an interstellar craft would have to be like to cross that distance. Well, the sharp-eared among you probably have heard there's a little bit of overdubbing on this little video. Well, that's because I made the same mistake that NASA made with a Mars probe, in that when I mentioned the distance out to Pluto, I said 410 meters. Well, that's in imperial measurement. It's 410 yards, not meters. It's 375 meters roughly, the furthest distance, about 7.4 billion kilometers that is. So it just made me think how easy it is. Mix up units,